All right. Here we have x is going to 0 from above, and the exponent's also going to 0. So again, we have an indeterminate form. And you can see why. If these numbers are just going to 0, if the exponent gets to 0 pretty quickly, then we'd be pulled towards 1, right? But then if the base goes to 0, 0 to any power should be 0, so we'd be pulled by 0. If there's some kind of balance between these two, we'd be pulled towards some number in between. Let's see if we can figure it out. Again, we've got a problem in the exponent, so our little natural log trick is a good one to try. Take the natural log of x to the x. Of course, if I take the natural log, I have to undo it. My purpose in taking the natural log was to be able to pull that exponent down using the power rule for logs. So I have exp of x ln x. Since the exponential function, the natural exponential function, is continuous, you can go ahead and pass that limit inside. And we have a limit. Let's see, the natural log of a very tiny number is very, very negative. So this is going to negative infinity, but the x is going to 0. So we have this indeterminate form 0 times negative infinity. And what we usually do in that case is we try to doctor it up by either moving the one that's making the 0 downstairs or the one that's making the infinity downstairs. To do that, you have to take a reciprocal, and so you get the other kind. So, alright, so I'm going to write this as exp of the limit as x tends to 0 from above of the natural log of x over 1 over x. Exactly the same thing in here, because if you multiply top and bottom by x, you'd be back to x ln x. But now we have infinity over infinity. And when you have infinity over infinity, you can apply L'Hopital's. So I'm going to apply L'Hopital's to that limit on the inside. We have the limit as x tends to 0 from above of the derivative of ln x would be the derivative of the inside over the inside, so that's 1 over x. And this is x to the negative 1, so the derivative is negative 1 over x squared. So we have e to the, if I multiply top and bottom by x squared, I'm going to get the limit as x tends to 0 from above of negative x. And that limit is easy to see that that's 0, and e to the 0 would be 1. So the limit in this case was 1.